All right. So if we read this problem, it says a taxi charges $5 minimum to ride up to 3 miles. So if we're going to write that as a piecewise function, if you get in the taxi and you ride 5 feet and then you get out of the taxi, how much money did you pay? $5. You can't pay any less than $5. You got to pay. Okay? So for the first piece of the piecewise function, we're going to say you're paying $5 if, and you could barely ride at all and you're still going to pay, right? Because you got in that taxi, $5 minimum, okay? If you ride up to 3 miles. So we're going to say if, and then what x values are we going to be between here? 0 and 3. Okay? What if you get in the taxi and then get out of the taxi?
That's still $5.
In theory, that's still $5, so we're going to say equals 0. If you ride 3 miles exactly, what do you have to pay? $5 equals 3. Okay? Okay? So before we go further, let's go ahead and write down what x represents. What does x represent in this problem? The number of miles. I'm going to be real specific. The number of miles. Okay. So if we ride between 0 and 3 miles, we're going to pay $5. And then they charge 50 cents for each mile that's beyond 3. Okay? So you're going to pay the $5 plus, how much more do you pay? 50 cents. So we're going to say, did somebody say 50 cent? 50 cents. And then do you guys remember from the video what I put in there? X minus 3. X minus 3, because you want to see how far beyond 3 miles you've gone. So if you're going 4 miles, then you pay $5 for the first 3, plus 50 cents times 4 minus 1, plus 50 cents for the extra mile, or 50 cents for whoever was in the back and send it that way. Okay? So we're going to say if what? X is greater than 3. Okay? What does f of x represent? Yeah, how much you're getting charged. The total cost or the total charge. Okay, so along the x-axis in our picture, we're going to have the number of miles. In case you guys were wondering, this doesn't only mean hashtag, it also means number. Or pound. Right? And then on the y-axis, we're going to write total cost. So number of miles, total cost. Okay. Our x's are from 0 to 3 and then bigger than 3. So how do we want to label our x-axis? By ones, probably. Yeah. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, it goes to 15. We'll call that good. Okay. Our y values are going to start at 5, and then they're going to go up by 50 cents each time. So how do we want to label our y-axis? If we go by 5s, that's going to be real hard to do 50 cents. We could go, so if we go by 0.5s, then we're going to go 1, 2, 3, 4, 5, and barely any higher.
1.
Yeah, let's maybe go by 1. Going by half is not a bad idea. It just means that you're not going to be able to fit much extra on your graph. But I would not judge you if that's how you wanted to do it. Okay. I wish that I had not written total cost so close to that line. All right, so our first drawing is going to be a horizontal line at 5. And I'm still going to do it kind of like we were doing it the other day. I've got my horizontal line at 5. And what part of that horizontal line am I keeping? So from 0 to 3, I'm filling both of those in, and I darken it in between, and then I erase the rest. Okay? This other one, I don't know about you guys, but this does not feel comfortable for me to graph the way it looks right now. Okay, so I'm going to go ahead and simplify this a little bit before I graph it. I'm going to go ahead and do my work over here off to the side. Okay, so I've got 5 plus 0.5 times x minus 3. And what should I do first to simplify it a little bit? Distribute. Okay, so I've got 5 plus 0.5x minus 1.5. Okay. If we were to write 0.5 as a fraction so that we can do rise over run, what would that fraction be? 1/2. Okay. So I've got 1/2 x, and then I've got a positive 5 and a negative 1.5. 3.5. Plus 3.5. Okay. So for that one, we're going to start on the y-axis at 3.5. And then we're going to go up 1 over 2. Up 1 over 2, up 1 over 2, and I'm going to lightly draw that graph in. And what part of the graph am I keeping? Says x is greater than 3. So I start at 3 and draw a hole right there. And then I go to the right of that hole, so I go on forever. And then I erase the left side. Whew, and I'm done. Yeah.
Because it's equation simple if you just plug in points.
You could plug in points if you want.
Yeah,
you're welcome to. Yeah, that's fine. That's totally fine. All right. Now, which one wins? The fact that this was filled in or the fact that there's a hole there?
What's the question? Yeah. What do you mean?
This one, it was filled in, so I'm asking, is it defined or is it not defined?
Oh.
So for the first one, it was filled in. For the second one, it was a hole. And I'm just saying, does that value not exist there? Or does the value exist there? It exists there. So we're going to say just because the second one had a hole there doesn't mean that point isn't there. It's still there. So we're going to say even though the second one was a hole, that point, it really is there. Okay? The way that some people think about it is they say that the second equation had a hole where x was 3, but the first equation filled it in. All right? That's like how people typically describe it, is the hole got filled in. So that value is truly there. Okay, let's try the next one. A store charges $15 per t-shirt for orders of 50 or fewer. Okay? What is our x value going to represent? Is x going to be a specific number?
I'm sorry.
Yeah, so x is a variable, the number of t-shirts. X is going to represent the number of t-shirts. Okay, so you pay $15 per t-shirt if you have 50 t-shirts or fewer. So how do we write that? So total cost, $15 per t-shirt. So 15
0 is less than x greater than, what's the other number?
50? I almost agree with you, but when you write it like this, you make it seem like if I buy 50 t-shirts, I only pay $15 total. 15x. So 15 for the first t-shirt, 15 for the second, 15 for the third. If I get 25 t-shirts, then I'm going to plug 25 in there, 15 times 25. Does that make sense? If I just put the 15 without the x, it would look like my whole order is $15 regardless of how many t-shirts I got, as long as it's less than 50. And it should be equal to? Should we put an equal to here as well? Is it really going to make a difference if you do? So either you say 15 times 0, you're paying $0, or we're saying you have to get more than 0 t-shirts for this to make sense. I'm okay with you guys not putting it or putting it. In this case, it's not really doesn't really matter, I guess. I'm going to go ahead and put it. We can say that not ordering t-shirts is an option. Okay? Now, this one says $13.50 per t-shirt orders of 75 or fewer, but more than 50. So, are they saying that you pay $15 up until the 50th t-shirt and then after that you pay $13.50? Or are they saying if you order enough that all of the t-shirts are $13.50? They're saying all of the t-shirts are $13.50 if you order enough of these, okay? So we're going to say $13.50 times X. It's not one price up until you get to 50 and then another price. They're saying if you buy enough, you get the same discounted price for all of them, okay? Do we see how that's different from the first problem? The first problem started at one price and then changed. The second problem, well, it didn't change, it added to it, I guess. The second problem said we really have two different situations happening. Okay? All right, so 1350 x if, and what do we write here? X is between, yeah. So we do smaller to bigger. Should we have equal to on either of these? The 75. Okay, $12.50 per t-shirt for orders that are more than 75. So how do we write that? If perfect. Okay, we're going to do one more together where I'm going to help you guys start, and then I'm going to have you guys mostly write it yourselves, and I'll check in on it. All right, it says the Postal Service charges $1.95 for a package that's up to 4 ounces. So if you have a 1 ounce package, it's $1.95. If you have a 2 ounce package, it's $1.95. If you have a 3 ounce package, it's $1.95. If you have a 4 ounce package, it's $1.95. Okay? After 4 ounces, it's 0.17, so it's 17 cents for each additional ounce. And then you max out at 13 ounces. After that, they're not going to take your package anymore. Okay? All right. So what does X represent? The number of ounces. The number of ounces. Okay. So go ahead and write that first part. It costs $1.95 for a package that is up to 4 ounces. If it's 1 ounce, it's $1.95. If it's 2 ounces, it's $1.95. If it's 3 ounces, it's $1.95. 4 ounces, $1.95. So see if you can write just that part. Anyone want to share what they got? $1.95. Okay. If less than or equal to 4. Should we add anything else to this part, this domain for this piece? Yeah, we got to say 0 because you can't have negative packages, right? Your packages can't weigh a negative amount. So we are going to specify it has to be between 0 and 4. Okay. Now for the next piece, do we not pay that $1.95? We still pay it. And then what do we do? We pay more. Okay, see if you can write the next part. So we still pay that $1.95, we just pay extra if we're above 4 ounces. You can't say 212 because you want to write something that could be 5 ounces, 6 ounces, 7 ounces, 8 ounces, 9, 10, and it's 17 cents per ounce. So this is going to be very similar to number 1. Not X. Not 190, because if you say 195X, you're saying $1.95 per ounce. Does that make sense? Okay. So how do we start this piece? You say 195 plus 0.17. Yeah, and we got to have X minus 4. What is the X minus 4? What does that part do? Yeah, it only charges you for the ounces that are above 4. You're not paying an extra 17 cents per ounce for the first 4. You're just paying 17 cents per ounce for the ones after the first 4. Okay. All right, and that's if, and what ounces are we allowed for this? More than 4, but less than 13. So 4 to 13. Can we include 13? Yes. Okay. So here's what I want.